Physics World.
Hello and welcome to the Physics World Stories podcast. I'm Andrew Glester, and in this episode we're going to be exploring ethics in artificial intelligence. We're going to hear how bias in artificial intelligence and machine learning is causing problems for the people we share the planet with. And we'll hear from someone whose work sees them working for the Large Hadron Collider at CERN, but also looking at how the COVID vaccine could possibly be distributed more fairly. The Physics World magazine this May has a series of fascinating features looking at artificial intelligence and this question of ethics. Reading through the magazine earlier this month, there was only really one choice for this episode of the podcast. And as some of you may know, I'm a lecturer in science communication at UWE Bristol, home, of course, to the Bristol Robotics Lab. And there was only really one choice for my first interview for this podcast, and it is, of course, my colleague, Professor of Robot Ethics at the Bristol Robotics Lab, Professor Alan Winfield.
In a nutshell, I've been working on robot ethics for more than 10 years, in fact, for longer than it's been a thing. And of course, really, robots are part of AI. A robot is simply an AI in a physical body. So pretty much everything that you can say about robot ethics applies to AI as well.
How were you working on it before it was a thing?
Back when I was doing a lot of public engagement, and for a while, of course, I was director of the Science Communication Unit. And when you do a lot of public engagement around robotics, you very quickly discover that people have worries, they have fears. In a sense, they're both fascinated and fearful at the same time, which is almost a unique characteristic, I think, of robots. So really, I then realized that robot ethics is something that needs some serious attention.
What are the concerns that people are voicing to you? Have they changed over the years?
Oh, yes, the concerns have changed, yes. But I think initially the concerns were very straightforward and kind of science fiction led in a way. How smart are robots, and should we be worried? In other words, should I be worried that they're going to be smarter than humans? That kind of science fiction led concern, but also very straightforward concerns about jobs. Will robots mean that we don't have jobs anymore? Things like that. I mean, concerns around AI now have shifted focus toward privacy, toward bias. I mean, the concern about jobs and about worries about the future developments are still there, but but AI ethics encompasses a much broader range of concerns than I think were voiced when I was, giving a lot of talks to families and school children and so on, 15 years ago.
As you say, artificial intelligence encompasses more than just robots. We encounter artificial intelligence a lot in our daily lives, and you've mentioned these privacy concerns.
Well, the privacy concerns are very serious because typically when you use AI systems, and of course you're using AI systems every time you do a search on a browser, you use AI systems whenever you order something from an online retailer. And whenever you do that, information about you is being collected. Where does that information go? What's it being used for? In fact, a number of books have been written. Susanna Zuboff has called it surveillance capitalism. And more recently, a wonderful book called Privacy is Power by Carissa Felith really points out that this mass collection of personal data, which Zuboff called digital exhaust. In other words, it's the information which nobody really thought about at the beginning of the internet. Well, not of the internet, the beginning of e-commerce. This is really e-commerce, except that Google did, and Google realized that there was money to be made out of essentially analyzing that personal data and using it to target advertising. So essentially, the original purpose of collecting this data, well, I suppose originally it was to improve the search engine, but then in order to make money, it became data to allow targeted advertising. And of course, one of the unexpected side effects, but very serious side effects of that, is that targeted advertising has been subverted to become political advertising. And therefore, arguably, this is not just a worry about privacy, but about democracy itself.
Is there anything we can actually do about that? If you're fighting against, political forces, big commerce, these really big companies.
Well, you lobby about it. You make a fuss. You boycott. Unethical. I mean, it's very difficult, of course, because of the fact that we live in an environment, a kind of online environment, which has a very small number of very large companies, monopolies, effectively. I mean, many people, I'm one of them, choose not to use Facebook, for instance. I choose to use a browser and a search engine, which does not collect personal data. So there are things that you can personally do about it. And it's very interesting that a number of these companies are suddenly deciding that privacy is important to them. And I think that's because recent developments like, for instance, Apple on the iPhone, the latest version of the operating system on the iPhone actually allows you to opt out of data collection. By the apps, you can actually turn off the collection of personal data. Now, when this was first launched, Facebook were very cross about it indeed. But interestingly, Facebook have now decided that privacy is important to them too, and I think they've probably seen that that this is the way things are going. That people are concerned about privacy. I mean, I forget what the statistics are, but a very large proportion of people using iPhones are now choosing that option. I mean, it may not feel very effective, but I think it is. I think these are, useful things to do.
What's artificial intelligence issues with bias?
First of all, I need to say, Andrew, that we're talking about a particular kind of artificial intelligence. And it's called deep learning. Deep learning is a technique based on artificial neural networks. These are rather mathematical abstractions of biological brains. They're very simplified. So if you want to build a facial recognition system, for instance, using deep learning, you essentially take one of these artificial neural networks. It's a pretty much a blank slate, if you like, and you show it a lot of images, and for each image, you give it the correct answer. So in other words, you're training the network, this large neural network, to recognize images, to identify, all of these images as, a young white man, or all of these images as an elderly Chinese man, or whatever. The problem is that if the images that the network is trained on are not completely representative of all of the diversity and ethnicity, gender, all of the variations, which there's a vast number of variations in faces, then the final system will be biased. In other words, it will misrecognize, it will misidentify people. And this is serious. This is extremely serious. There are, cases where misidentification because of a poorly trained, it's an engineered system. It's a badly engineered system. And one of the reasons these systems are often badly engineered is that curating a large data set takes a long time and is expensive. So what companies have been known to do is to scrape data off the internet. And if you do that, of course, you will end up with an unbalanced, unrepresentative data set. So, as I say, there are cases where people have been misidentified and wrongly arrested. So this is serious. This is, this is not trivial. And there are moves afoot to ban this kind of facial recognition because of the problem of bias.
It's not a deliberate thing that people are doing. It's simply that the data sets that already exist are biased.
I'm not sure I can make a judgment. I mean, certainly, I think some of the early attempts to build, these facial recognition systems were guilty of naivety. I wouldn't say they were negligent, but they were certainly rather naive in not realizing the consequence. I mean, if you understand how these networks are trained, and that the training data is key to that training, then it should be obvious. I find it hard to understand how good engineers missed this.
Much more from Professor Alan Winfield later in the podcast. But I mentioned that this month's Physics World magazine is chock full of fascinating features and articles, and one of them was written by Juliana Fotopoulos, looking at this issue of ethics in AI. Juliana has a bit more detail on the facial recognition software, specifically a disturbing bit of research carried out by Joy Bolognini. It's called Gender Shades.
This was actually part of her master's thesis. So the study looked into 3 different systems that were developed by 3 different companies. And she found that they misidentified darker female faces almost 35% of the time, while they worked perfectly, or almost perfectly, I think it was 99%, on white men.
As we've heard, this is due to the software being trained by data which was heavily biased in the first place towards white men. Another shocking example comes from Jackie Alcine. Here's Juliana again.
A software developer who tweeted that Google Photos had labeled images of him with a friend as gorillas, which is quite scary because it means that, the algorithms are trained by the data that we give them, which can be biased or can be wrong or can be unfair from the beginning. And the solution as well sometimes is quite problematic. So for this one, Google managed to fix the issue by deleting the word gorilla. So now, if you put an image of a gorilla, it won't actually tell you it's a gorilla because they've completely deleted that. But there's also even voice recognition. So there was a program that wouldn't detect women's voice because it was higher pitched. So it was trained on, probably mostly male voices, and and the high-pitched voice that a woman might have in some occasions it wasn't identified. So it's simple little things. The most shocking to me that I hadn't realized, and especially because it's quite relevant to what's happening now with COVID, is I remember reading in America that oximeters should be used to identify whether your oxygen levels were quite low, which meant that that something was going wrong and you should go to the hospital because you might have COVID. And these machines, they work with infrared, and they're also tested in light skin. So in darker skins, they can't actually measure. I mean, in lighter skins as well, they're not 100%. Obviously, there's a bit of some accuracy errors, but there's not enough data on darker skin, so it actually doesn't read, the measures are not correct. It's been quite a big issue for people of color going to hospital and being admitted to hospital because the oximeters don't work. And it's the same technology used in soap dispensers as well. So you go to the bathroom, in the public bathrooms, and you put your hand and it can't detect your hand, so they don't work. and it might be kind of funny between friends, or but it shows that it can be a wider problem.
Back in 2009, Sophia Noble's book, The Algorithms of Oppression, shared some more disturbing information. Here's Juliana again.
If you Google the terms Black girls or Latina girls, the Google ad portal would often offer keyword suggestions that were linked to pornography.
Wow.
When you type, for example, in Google search a word, and then it comes up with suggestions, or what the actual search is, and these words, so Black girls, Latina girls, or even Asian girls, would come up with pornographic content, whereas this would not happen with white men, especially white men, and much less with white girls as well. More and more companies are actually using hiring algorithms. I think it was Amazon that had a hiring algorithm, and it was found to be biased against women based on their hiring practices before. So anything the algorithm would find that had anything to do with women's sports or a women's college or university, as a candidate, they would automatically be left out.
It's just incredible, isn't it? I believe there's been a problem with the legal system as well.
It kind of shows how scary and how powerful these systems can be, and how harmful they can be as well. ProPublica did a really nice investigation, I think it was in 2016, of a legal risk assessment software, which they use in courts in America to predict which criminals are most likely to reoffend. So the judges base their decisions about their bail settings. This really interesting investigation led by ProPublica found out that Black people were almost twice as likely as whites to be labeled as a higher risk. And it didn't matter what kind of, how severe the crime was, or the actual likelihood of reoffending. It was literally just based on their colour. They would have to stay in jail longer, unfortunately.
It's just incredible, isn't it? The computer's effectively a mirror pointing back at us and saying, yeah, you've been racist and sexist for a very long time.
Exactly. It's just, all of this is just reflecting, who we are as a society, and, all the problems and issues that we have in society. It's a reflection of that. And unfortunately, it's also amplified within these computer systems. So, we can see them even more.
So is there anything that can be done about it? I mean, you can delete the word gorilla from the thing, but that doesn't seem to be the proper solution. What can we do about this?
Yeah, that's definitely not a good solution. And it is, it's a problem that's embedded in society, so which becomes more complex, because we would have to get rid of, the sexism and the racism and all the isms that exist, which is quite hard. I think one of the main things is to actually be aware of it, and to be aware of the limitations that these computer programs have. If we're developing laws or, making decisions based on algorithms, then, we need to know that there's limitations, and it could be wrong, or it can be, harmful to some individuals. And especially people that are building them also need to be aware and need to be more responsible, I think, to tackle the issue, because it's not only a technical issue, if that makes sense.
I wanted to understand a bit more about how this machine learning and artificial intelligence works. Here's Professor Alan Winfield.
These neural networks are collections of very simple elements. Each element represents, if you like, it's a mathematical model or a computer model of a biological neuron. And rather like biological neurons, there are connections between them, and the connection strengths, in other words, the weights of each connection, are the things that are varied when you're training the data. So essentially, there's a mathematical process which modifies all of the thousands of connections in this neural network as you present new data, as you present training data. And that's called learning. It's supervised learning. If the data is biased, then the trained network will be biased.
We'll hear more again from Professor Winfield later in the podcast, but I wanted to get a picture of this from someone who's involved in physics research as well. Savannah Tice is in the heartland of AI and machine learning.
I'm a postdoctoral researcher at Princeton in research computing. My background is in particle physics. I did my PhD at Yale on the Large Hadron Collider at CERN, doing a lot of like software development and data analysis there. And now I've transitioned a bit more into machine learning research. The Large Hadron Collider collides tons of protons at almost the speed of light to produce new particles that could maybe help us answer questions that are still outstanding in physics, like the origin of dark matter or the quantum structure of gravity or different kinds of things. So it produces a massive amount of data. It's colliding like millions of protons a second, which produce a bunch of particles that are then like measured by these really big like multi-story detectors. So that produces a ton of data. So a lot of the work in those kind of experiments is kind of akin to software development or data science work. So I did some amount of machine learning stuff there. I worked on an algorithm to identify a certain type of particle that's produced from those collisions. And I worked on some searches for new physics as well. So trying to dig through these massive data sets to find very rare signals that might indicate new physics. And then now I still work a bit with the LHC, mostly working on software for the upgrade. We're going to upgrade in a few years to collide even more protons at the same time. So the data size is going to increase even more. And a lot of the algorithms that we use right now to measure the data produced from those collisions don't scale well enough to work with that new data size. So I'm looking at using kind of new machine learning techniques to deal with that increased data size.
But you've always been drawn to the more ethical side of artificial intelligence.
Yeah, well, ethics is a huge part of machine learning and artificial intelligence work. I actually do some work directly in kind of AI ethics. Back in grad school, when I started getting into machine learning and AI research, I started going to conferences in the field rather than just like physics conferences and kind of learning about the ways that machine learning is used in non-scientific applications. So the way that it's used, by big tech companies and even by governments and different kinds of things to make very high stakes decisions. And since I started going to those conferences in 2015, it seems like more and more stuff has been uncovered that a lot of these systems that are deployed in the real world are not really always quality checked for bias. They're trained on historical data and just therefore replicate human biases. I talk to physicists about this a lot, and there's often, like why does this matter for us? Like we are not using human data in our research, and I think there's like several reasons that it's really important for even people who don't consider themselves like building I guess kind of human facing or societal facing systems to care about this stuff. So like we're all members of society still, so we're being affected by these algorithms. Your colleagues, your communities, like everyone that is being affected by this. So you have kind of a I feel like societal duty to care about these things, and especially as like a technical member of society who is building algorithms just like this. Maybe you're not using human data right now, you're looking at galaxies or particle collisions. You still have a really rich technical knowledge that a lot of people don't have. So you can offer a lot of help to your community to like helping them understand these things, like make sure they're informed about systems that they're participating in, whether they want to participate in them or not, like how their data is being used, all of these kind of technical questions. And then also, like, we know a lot of physicists don't stay specifically in the field of physics forever, particularly people who are doing like AI and physics. It's a lot of grad students, it's a lot of postdocs, and there's not that many faculty jobs. And a lot of people go into data science or big tech, machine learning research. Like one of my best friends, we did our PhDs together at Yale on similar subjects. Like she did her first postdoc at Facebook AI, and then now is at Google DeepMind. So like it's a very common kind of trajectory.
So you're right in the middle of the machine learning community there, and there's been a bit of controversy about Google and AI recently, which, as I understand it, has it been the talk of the community to some extent?
I guess it was probably end of November 2020. Timnit Gebru, who is like a very famous, both technical AI researcher, but also really involved in the ethics space. She was like one of the founders of Black in AI. She was one of the heads of ethical AI at Google. And I I was actually like on Twitter when this was happening. Like I started seeing her tweeting that she had been fired for over concerns about a paper about large scale language models, which are like natural language processing models that try to like infer patterns in language and kind of reason about like sentence construction or information, and that forms the basis of Google's one of those large models is the basis of Google's search engine. So when this came out, I was like, how could Google possibly do this? Like this is never gonna look good for them. Like whatever happened, she's hugely important in the field. Like this is gonna bring so much attention to their kind of questionable practices. And so, kind of Google's side of the story was that she was on this paper with some external collaborators. All papers have to go through internal Google review, like academic papers have to go through internal review, which, according to a lot of people who work at Google, is never like a scientific check. It's just kind of like a easy quality check. Like they don't even dig into the science of what you're doing. But this paper had some very negative implications for Google and kind of the foundation of like their core operations. So they told her that she couldn't be on the paper. Her and everyone else who was Google affiliated had to take their names off of it. And she asked for an explanation, basically like what process the paper went through. And there were other things going on, like a lot of diversity concerns. And, she said if they weren't willing to have a discussion, that she was going to plan to leave in a couple months. Like she was going to work with the team to transition, but she like didn't feel that she could, stay there because they're basically suppressing like academic freedom, right? If they're not willing to explain scientific reasons that a paper can't be published, you're not doing at that point actual research. So they cut off her email and we're like, okay, you don't work here anymore. Like, we don't want to have this meeting and we've decided you're quitting now. And then the other co-lead of the ethical AI team was fired a few months later. And I'm still like in shock that this happened because it's just so bad for Google. Like it's like this conversation is still going on. Like people are refusing Google sponsorship. Like there's been prominent researchers who have like won grants from Google and turned them down, which would like never happen before. A lot of the affinity groups like Women in Machine Learning, Black in AI, like Latinx in AI are questioning, and some have already decided whether they want to accept Google sponsorship for any of their events anymore, whether they can like consciously be publicly affiliated with Google. So it's been a huge deal.
So your friend worked at Facebook. Does she share your concerns about ethics and artificial intelligence?
So this is a really interesting question. I mean, this is something that comes up a lot in my friend groups. Like I do have a lot of friends who work at Facebook, Google, like that's where you work in if you're a machine learning researcher. I mean, they even sponsor a lot of academic research. So this has been a very interesting conversation over the last couple of years. Like there's definitely her view, and like a lot of my friends' views was that, it's better to try to change things from the inside. So maybe you don't agree with everything that the company is doing. You don't necessarily support some of the things they're doing on the product side, but like one, you're doing more theoretical research, like you're not product facing, and two, like, you know, they're not going to listen to someone outside the company to kind of change their AI ethics practices. So that was kind of the argument that I heard a lot. But then when all this stuff with Google happened at the end of last year, like the firing of Temnet Gebru and Meg Mitchell, there's been a bit of reckoning, I guess, since then with like, is that really a valid argument that all of these researchers are making? Like, that kind of indicated that maybe even being inside the company, like you're still not able to change anything. And if you push too hard, you won't be at the company anymore. These are very thorny conversations for sure.
Are you on Facebook?
I am. I I tell my like friends a lot that I'm trying to go like one step at a time. So I quit using Amazon now like almost a year ago, I guess. And like that was a that was like a big adjustment. And so like I kind of know that I don't want to be on Facebook, but it's there are like people that I'm connected to that I don't know how else I would stay connected to. So it's very hard to leave, which is like the point, right? Like that's why so many people are on there. That's why this whole thing works.
Yeah, I'll let you off. It's completely how it works. Yeah. You say that you've been involved in all these other projects. Could you tell us a bit about them?
I guess so far it's focused on like community health and community needs assessments. So before COVID, I was working on trying to understand region specific like indicators of opioid abuse behavior in Appalachia and how historical kind of policy and like infrastructure played a role in why the US opioid crisis is worst in that particular area. But then once COVID happened, I kind of transitioned to some more COVID focused stuff. So we built this like community needs assessment tool that tried to like parse out different types of COVID impact. So like a lot of the analyses just kind of looked at like very broad strokes and said like, oh, this area of the US is like most vulnerable to COVID or to impacts from COVID, societal, like socioeconomic impacts of COVID. And we tried to go a step further and be like, this area, you know, is most at risk of like public health concerns and maybe hospital overwhelm. This area is more at risk of like economic impact, like given, and this, you know, area could use more like mobile health resources. This area could use more of this kind of resource. So trying to parse out like different types of risk. And then that has expanded now. Like we are now working on a vaccine equity project, trying to see like if we can use data to kind of motivate vaccine sharing amongst countries, vaccine diplomacy. And then we're also working with Planned Parenthood actually like on a analysis looking at how to best target sexual health education resources, particularly among teenagers and young adults. So trying to understand like the landscape of what's already being done, what different school districts have different like policies around what's taught, like what kind of education is allowed, and then private schools and charter schools also have different laws. So trying to figure out or regulations. So trying to figure out like where they can best put their resources to like reach the people who need it the most, who aren't being covered by other sources. And then also they're interested in looking at how COVID has affected things too, because they kind of have this hypothesis that like in some areas, funding for sexual health education was cut during COVID because students were at home. And so school districts were like, oh, we don't need to spend money on this anymore. And we've seen preliminary data that like actually teen pregnancy increased or like at least stayed the same during COVID. So that argument wasn't really valid.
That's a surprise.
Shockingly.
I suppose for a lot of people, when we say, it's certainly something that I'm finding if I tell people that I'm making this podcast about ethics in artificial intelligence, one of the first things that they think about is either driverless cars or military robots or, you know, something like the singularity.
I think we're doing very impactful and often like very harmful things right now with artificial intelligence. Like we're having an AI ethics crisis already because these like rapidly developed systems that aren't always quality checked or bias checked are being used to make, I think, way more decisions than people realize. Like it affects, and we're starting to see more stuff come out about this, like the way social media curation algorithms are influencing like people being radicalized, right? Or we're seeing more stuff come out about this, but I think it's a real pressing concern right now. Like people should be worried and caring about this right now, not just in some future where like maybe we're overtaken by robot overlords.
Alan Winfield, in his role of Professor of Robot Ethics at UWE in Bristol at the Bristol Robotics Lab, has been involved in some fascinating research into the ethics of robotics and has reached some rather interesting conclusions.
Yes, I mean, some years ago, I became interested in the question of whether a robot could make ethical decisions. In other words, decide its actions on the basis of moral considerations rather than, if you like, quotidian task achievement. It was really a piece of theoretical research, if you like, a piece of robotics research. Although, of course, it did get me interested in the question of whether, if we could make ethical robots, whether we should. So there's that kind of meta level ethical question, should we make ethical robots even if we can? In fact, I've decided the answer is no, we shouldn't.
Okay.
But I became interested in the technical problem of how you would make a robot that could consider ethical issues, and the thinking went along these lines. So I should say that I started by thinking you couldn't make an ethical robot. So I kind of changed my mind over the course of this work. And at the beginning of the work, I really thought about a kind of thought experiment, simple thought experiment. So imagine, Andrew, that you're walking down a pavement and you see someone about to walk into a hole in the pavement. So somebody else, maybe they're looking at their mobile phone, not watching where they're going, and they're about to step into an open manhole cover or roadworks, whatever it is. Now, my guess is that you will try and prevent them from falling into that hole. Mm-hmm. Now, the question that I asked myself is, how? Well, it's not just because you're a good person, Andrew. It's also because you have the ability to predict the future. It's because you can see that this person is walking towards the hole. You can see that they're not paying attention, and therefore you can predict with some certainty that they will fall into the hole. And you can also then predict what might happen as a result of your intervention. So if you're a long way away, you might be able to predict that you can't physically intervene, but if you shout, you might be able to get their attention or something like that. So it's this ability to predict the future that I theorized was key. So we started then to look at robots that have a simulation, that is a computer simulation of themselves and the other actors, if you like, in the environment. In this case, we used other robots acting as proxy humans, so that the robot can simulate itself and the other actors in its environment in the next few seconds of time ahead. So in other words, we gave the robots the ability to predict the future, not very far into the future, and it's a very simple scenario that we're talking about, but nevertheless, it worked. So we did, a whole bunch of experiments and wrote papers and so on that particular method of building simple ethical robots. Mm. So it was really a piece of if you like, fundamental research. It caught the headlines, of course, because of these ethical robots, and also we for some fun, if you like, we gave the robots ethical dilemmas. So instead of having one robot to prevent falling into a hole, we put two robots in, and we didn't cheat. We used the same code that the robot used for one other robot and as for two robots. And interestingly, we found that the robot didn't work very well when it was facing an ethical dilemma, which is kind of interesting because it shows us that robots cannot solve ethical dilemmas any better than humans, and why should they? So there's a kind of philosophical, reflection on that as well. It gets you thinking about, ethical dilemmas in a way that you wouldn't have done before.
So why have you decided that we shouldn't make ethical robots then?
Well, one of my colleagues, in fact, who worked with me on some of these experiments, called Dieter van der Elst, came up with a very elegant experiment where he programmed a shell game. So this is the game where you move around cups and somebody has to guess where as it were, the prize is, or whatever it is, the token inside the cups. Except that in this case, he had a robot helper. So there's a robot that is helping you to win the shell game. So it's an ethical robot. It uses the same code as the previous experiments. And of course, because the robot is very good at watching what's going on. I mean, this is this is the kind of thinking. Then it knows where the prize is. Where the coin is, or whatever that is in the shells. So he programmed it initially to be ethical, so it would help you win the game. But then he discovered that if he changed the code just a tiny amount, he could convert this ethical robot into either a competitive or an aggressive robot. So a competitive robot would beat you, would essentially play against you. An aggressive robot would make sure you never win.
Right.
And the lesson we learned from that, and the paper we published is called The Dark Side of Ethical Robots. The lesson we learned is that it's very, very easy to make an ethical robot into an unethical robot. In fact, so easy that that's probably a good reason for not building ethical robots in the first place, because they would be vulnerable, particularly vulnerable to being hacked. Think of a robot with an ethics chip. You wouldn't want that ethics chip to be hacked, would you? Or replaced with, reprogrammed, overwritten. Because, if that ethics chip were in a driverless car, imagine you hack a whole fleet of driverless cars and you turn them into weapons effectively. So the thinking is that a hackable ethical robot, I think, is more dangerous than a hackable aethical robot. In other words, a robot that doesn't have any ethics at all.
I suppose I'd like to finish on a bit of a positive. So what's the most exciting area for artificial intelligence for you at the moment?
Gosh, that's a difficult question, Andrew, because I'm a professional worrier. I tend to think about the downside. That's part of your job in a sense. But actually, going back on the work that I mentioned earlier, this idea of robots that can predict the future. In fact, we call them robots with simulation-based internal models, and we're using those for all sorts of applications, not just ethical robots. So I have a current project where we're using that same technology to build a robot that could explain to you why it's doing its particular action. So you could ask the robot, why did you just do that? Which is an interesting question to ask a robot, particularly if you're an elderly person with a robot helper, a robot assistant. Or even more interestingly, you could ask the robot counterfactual questions. You could say, robot, what would you do if I fell on the floor? Or robot, what would you do if I forgot to take my medicine? So this ability for a robot to be able to predict look a little, way into the future, I think is a very powerful ability. And in fact, in the same project, we're also developing what we call an ethical black box, which is the robot equivalent of a flight data recorder in aircraft.
I did want to end on something positive, and that's certainly some very exciting developments going on there at the Bristol Robotics Lab and in robotics more widely. But I don't want to detract from the importance of this problem of bias in AI. And I'd like to thank Professor Alan Winfield, Savannah Tice and Juliana Fotopoulos for talking to me. Don't forget you can dig more into this topic in the May edition of the Physics World magazine, and I can really strongly recommend Juliana's article on this very topic. Next month, we'll be talking to Carlo Ravelli about the weird and wonderful world of quantum physics. And thank you very much for listening.
Physics World.